Hello everyone. In this session, let us take up a case study for different ways of generating a program for the given problem statement. Let's assume that if I am taking the addition of two arrays, wherein the size of each array is 100 integers. So it's something like, so I just need to add two arrays where each array has how many integers? It is of 100 integers. So how to add it? So for that, let us generate a program now. So before I start showing you the program, how to generate all that, so first I want you to understand something right here, my dear students. Say for example, if you say 100 integers, okay, you will be having like this. So here, okay, so it will be like this. This is what array 1. If you assume that this is the array 1, and at the same time, if you assume that I'll take up one more array, if we give a different color, you see, my dear, here we did not specify what what values we have. As of now, it is, let me only specify the indexes. Let's assume that index 1 0 1 2 3 4 5, something like this. Okay, till when is a point, as I hope you know that. So every integer, the size of every integer is of 3 bytes. Okay, as the size of every integer is of 3 bytes, so understand clearly right here what I'll be showing. Size of every integer is of 3 bytes in this scenario. So the first 3 indexes, okay, for your understanding, let me put separately like this. See, these 3 0 1 2, right, this 0 1 2, whatever we have, these three complete 3 3 bytes makes one complete one word. So here I'm just showcasing that. See, these three bytes makes one word. Okay, so you at the same time see 0 1 2 3 makes one word. Let me make it different color. Again 3 4 5 will be separate word. Again 6 7 8 will be the different word. Try to understand, and it goes on like this. So in that perspective, okay, in that perspective, when you say that there are 100 integers, means it means to say that 100 words. I repeat, 100 words. So whenever you have 100 words, right, whenever you have 100 words, so total number of bytes in that, it will be around 300. I repeat, it will be around 300. So in that perspective, so it will be, you understand, this 298, this is 299 and 300. So this is how, my dear, try to understand total number of bytes in that, in the first array, it is of total 300. Why 300? Means because every word, every integer is of a word, and every word is a 3 bytes, and as we have 100 integers, so you need 100 words. 100 words means total 300 bytes, right? It will be something like that. So in the same way, so this is the array 1. If I consider the same way, I'll consider one more array, which let's assume that it is a array 2. Now again same way, the array 2 also, first 3 bytes makes one word, right? This is different. 0 1 2 is different. Again 3 4 5, again 6 7 8. So your list goes on like this, right? So I hope you are getting my point. If not, you try to understand. So here, so this is the first word, right, first integer. So what you have to do, in the sense, if I have to add these two arrays and place it in a new array, so this is the new array. In the sense, same way, the whatever the integer available in the first 3 bytes, which is first word, I have to add, okay, I have to add and store into this 3 0 1 2, right? In the same way, 3 4 5 from the first array, So I need to add with the 3 4 5 bytes of second array and store it with the 3 4 5 of array 3. So that's how my process should go on in that perspective. So what I'm going to do right now, okay, so as usual, so as this is a uh, a program, let me generate in SIC. First let me generate in SIC. So as usual, I'll say add array as the name of the program. So start and zeros, I'll see. Then now when it comes to declaration, here you can observe, so I need the 3 arrays. Okay, here I need 3 arrays, array 1, and I'll be declaring with 100 words, because here we said that array of 100 integers. Same way I'll declare with the second array also, I'll declare with the 100 words. Same way array 3 also with the 100 words. Once after I am done with that, okay, once after I am done with that, for initializing the X register, so I'll be using one more keyword as word 0, right? So this kind of constant declaration should happen at the beginning instead of at the ending, right? So then next, like whatever the number of times we will be iterating. So here you can observe, I hope when we discussed about the memory architecture of SIC and also SICXE, we said this. So every word will be addressed with the lowest byte address. So in this, as we mentioned that the 0 1 2 is the one word and it is addressed by using the lowest byte, which is 0. So this 0 1 2 will be addressed by using 0. Same way 3 4 5 will be addressed by using 3. 6 7 8 will be addressed by using 6. 8 9 9 10 11 will be addressed by using 9. So in a word, so it will be addressed by using the lowest byte address. So in that perspective itself, now also I'll be initializing the X register to the 0, right? And if you ask me how many times this will be repeated, because there are 300 bytes, but 100 words, definitely 100 words, and 300 bytes, as there are 300 bytes we have in the given array right here. So if how many times it will be repeated, okay, how many times it will be repeated, that is where you have to very much bother about it. So I need to repeat for 300 times. So I'll say that maximum number of times I'll be repeating it is for 300, because there are almost 300 bytes, is it not? There are almost 300 bytes. Later, next, so then later, so here as once after I initialize the X register with the 0, then later I can start performing as LDA, okay, LDA from the array 1 comma X, okay, array 1 comma X. So I'll be pushing the first word, whatever it is indexed by 0, X, what is X value of X right now? It is a 0. So you will be taking the first word, which is in the position 0 1 2, and will be put into the accumulate register, for which you will be adding, okay, for which you will be adding the same array 2 comma X. So whatever it is pointed by X in the array 2, which is what is the value of X? It is the 0. So when the value of X is 0, one word which is constituted is 0 1 2. This is the word which will be added with the 0 1 2 of your array 1 as well in the accumulate register, but the result is still in the accumulator, that I am going to put it into the array 3. When I say array 3 comma X, so again same way, wherever it is pointed by X, what is the value of current value of X? It is a 0. So you will be considering the 0 1 2, the three byte values, which is 0 1 2. That is where the resultant will be stored at, right? Now you are done with the first word, addition of first word in the first array to the second array, and resultant is also stored in the first word space of the array 3 as well. Now I need to increment. Understand, my dear students? Now I need to increment. I need to increment means what? So as I said, right now we are in the 0. So by using the 0, we have considered the first word. Now we need to consider 3 4 5. We don't have to consider 1 and 2, because it's already considered by having the index 0. So we need to consider 3 4 5 of the array 1, array 2, and array 3. So in that means, for the X you need to add 3 to it. I repeat, for the X you need to add 3 to it, right? The reason why you want to add 3, because here, okay, so here whatever you did, whatever the array addition, what you did, it is by having the array index is array index is of 0. Now you need to add 3 to the x. So if you add 3 to the x, so that after this 0 it will jump to the 3 again. From 3 to 6 it has to jump again, from 6 to 9 it has to jump, like that. Every time how many times it has to jump? In the sense it is 3 times, is it not? So what I'm going to do, or how to do this, how to achieve this, is a very important point, my dear. So how to achieve this? In the sense, for that itself, so whatever the current value of x, okay, whatever the current value of x, that current value, for that current value of x, I have to add 3 to it. How to add? See, at any point of time, as x has 0 right now, there is nothing like you'll be using directly as add 3 to the x register. It is not possible, because whenever you do this add 3, it will be added to the accumulator register. I repeat, it will be added to the accumulator register, not to the index register. At the same time, there is no possibility of saying that LDA x, thinking that x, first you push the x onto the accumulator register, then you perform this add 3. So this is also not possible, because you can't push the x to the accumulator register directly in our SIC. Whereas in our SICXE, we have the register to register movement, whereas in our SIC, no. So what can be done? Okay, what can be done? In the sense, for that purpose itself, this x whatever we have, okay, this x whatever we have, that is the variable we are going to tackle such a way that, okay, here what I will do, let me make use of one additional register, or let me make use of some one additional variable. I'll say that index, some variable. You can make use of any variable. So as of now, I'll just say that index, for which I'll be just allocating the memory space as one word. Okay, I'll be just allocating the memory space of one word. That one word itself, okay, that one word of itself, I'll be taking up right now. So what I'll do, I'll just initialize the accumulator register with the 0, and at the same time I'll also do that STA index. You observe what is happened. Index is initialized with the 0. Then later here what I will do, LDX index. So what has happened? X is initialized with the 0, right? Then later, yes, I do this right now. Array first word of array 1, array 2 is added, array 2 is put into the array 3 as well. Now here what I'll do, I'll just push the index onto the accumulator register, for which I'll be adding 3 to it. Then that itself I'll be using for the next index. So what I'll do here, I'll just insert 3 more lines here. Okay, see what I'll do now. What has happened? Index is pushed to LEA. First of all, what is index? It is a 0 which is initialized here. So that index is in the accumulator, for which I added 3. So that whatever I added, okay, whatever that I added, that I have to, I'm just again put back to the index. Okay, again I'll put back to the index, and also I'll do the comparison with what? When I do COMP, the one parameter is defaultly accumulator register. What does accumulator register contains now? It is 3, because a 0 is pushed to the accumulator. Again, that is for that you added 3. So accumulator has 3 in it right now. For that 3, you are going to compare with this max. So does the 3 is less than max or not? So I'll say JLT loop. Where to put this loop? I'll just put this loop, because this is the same index. Again, I have to initialize with the X register. So here I put the loop. So here what we did now, in the sense, so you consider the first word again for incrementing by 3 times. I repeat, for incrementing by 3 times. So what you are doing, in the sense, you are putting that index value onto the accumulator. For that you will be adding 3, again putting back to the index itself. So index has become 3. That your accumulator content is still 3, that is compared with the max. What is that max? It is a 300. Until this accumulator is less than, that's what index value is less than the max. So you need to jump back to the loop and continue the same. Now what is the value of this index? It is 3. That is itself you push it onto the X register. As now 3x is the 3, whenever you do this LDA array 1 comma x, so it is what? The word, whatever it is constituted in the 3, 4, 5, that is the one which will be taken up for the addition from the array 1, 2 and the array 3. right? That's how we'll be generating. This is the program in SIC. For at the end you'll just have the end instruction. That's it. This is the program in SIC. Whereas when you ask me in case of SICXE, okay, if you ask me to generate for the same process how to generate in SICXE in the sense, so however we have the immediate addressing mode, so I don't have to declare these constant values. Even I don't need, I suppose I don't need this index as well. I'll show you how, right? So what we are going to do in the sense, so let me delete it off everything. So let me come from the beginning. So what I'll do, I'll just initialize LDX to the #0 as usual. Okay, LDX #0. Once after LDX, that's what X register is initialized with the 0. Now to have the maximum count, I'll just place it into the T. What is the maximum? This is a 300. Whatever here I made use of max 300. So for that I am using LDT3. Then again here, okay, here actually one more variable. This is supposed to be initialized here because I am only declared max and the 0. So I must also declare here a 3. What is the value of 3? It is the word 3, right? Because every time that's what you are adding, right? For this 3 purpose also, I don't need the variable like this, so I can make use of S register for the 3, right? So now let me start the process as usual. LDA array 1 comma x, as usual I'll do it, array 1 comma x, right? Then again add array 2 comma x, right? Next sta array 3 comma x. So what has happened, whatever the whatever the byte which is pointed by x, so x is the current value of x is 0, so 0 1 2, that is the word which is pushed onto the accumulator register, that is added with the second array 0 1 2, and again it is placed onto the third array which is in the same place of 0 1 2. Once after you are done with that, now again as usual you need to increment the x by 3. You need to current value of x need to be added with the value 3. So what I'm going to do, I'll just make use of add r, okay, yes comma x. What is yes? First of all, yes is what? 3. So 3 will be added with the x. I repeat, 3 will be added with the x. So x has become 3. I repeat, x has become 3 right now. Later it will become 6, 9, like that. Every time increment by 3 times it is happening. Now I'll also compare x with the t. What is the current value of x? It is 3. What is the t? T is what? 300. So is it both are same? Is it less than, greater than? That you have, based on that you condition itself, I'll be jumping to the loop. And where to keep this loop? I'll just keep the loop right here. So because the current value of x has become 3, so again next 3 bytes will be taken care. The next 3 bytes means next word will be taken up. So that's how. So this is the program in SICXE for the same purpose of addition of 2 arrays of 100 integers. Okay.